But I'm happy to basically say, like, if you're at all questioning whether or not I should even have that one bottle, 20-ounce bottle of Code Red Mountain Dew. I say this because my wife had kids, and I've been through this. I probably wouldn't do that. I'd probably recommend don't even take that risk, right? Because we just don't know, we just don't know enough about like what even transient exposures, right? Like we haven't even in mice,
Right.
we haven't done that experiment where it's give it, you know, once a week instead of constant chow, right? Or give it a
Yeah.
couple of doses during a
Yeah.
certain period.
But you said also you didn't give it the whole pregnancy, right? You still did give a fairly limited amount.
Yeah, and that was, in my mind, really important to say. But sometimes you'll hear the advice where like, oh, my doctor told me to only do, like I can
Right.
have this
Right.
occasional. I
Yeah.
don't even know if I would take that chance,
Right.
right? This
I mean,
doesn't seem.
going back to your own experimental setup, I think you said this too. Like you gave only a modest dose of high fructose. You gave it for a limited window in the pregnancy, and you gave an amount such that the females were not gaining extra weight or showing signs of metabolic macroscopic
Yep,
obvious signs of metabolic
yep.
disruption. So they looked fine.
They looked
They
fine.
seemed
Yeah.
healthy.
And that was an important, I mean, the scientific process, you have reviewers criticizing it. And that was an important criticism was just show us what the weights are. And I think it was an important piece of data kind of buried in the supplement somewhere. But if you see, our mice were not gaining any more or less weight and they didn't have different metabolic metrics. So yeah, that's a great point.
Yeah, yeah, interesting. Okay, so where do you guys see this going next in terms of your own work?
Yeah, there's two angles. Well, three really, but one of them, as I mentioned, we our microglia have this transporter. Evolution doesn't do things for a reason, right? There's no intention behind evolution, so it's entirely possible that this is just something that's remained behind and doesn't have a purpose. But we hypothesize that it does. And so, why is this transporter expressed in microglia at such high levels, particularly in it? So it turns out the expression of this transporter in humans and in mice goes up with aging.
Yeah, yeah,
And
interesting.
so the question is, does it serve a role? Does it actually do anything? I told
Yeah,
you we've now deleted it. What happens to
right.
that organism, right?
Why is it there in the first place? What's it
Why is it
doing?
there in the first place? And I get asked this question a lot, and I think it's a really important question. I have weird speculations about hibernation and maybe it's keeping. So, right. So we talked about how microglia they do this phagocytosis early in life.
Yeah,
But then after these development windows, they sort of go quiet. I don't want to say they're like quiescent or completely quiet, but
yeah.
they do much less
Right.
phagocytosis.
There's less for them to do,
Less
ostensibly.
and in fact, it's sort of a Goldilocks model, right? Like you need them to do enough, but you don't want them to do too much too.
Right, right, right. Of course. Yeah, that
And
makes sense.
so the hypothesis is that maybe this is sort of how Goldilocks ensures the appropriate temperature, right?
Right.
So that not too hot, not too cold is through the limited use of fructose through this transporter in
Yeah.
adulthood and aging.
Yeah.